Welcome to the Open Matters podcast, where we talk about open source matters because openness matters. Today, we're cracking open a question you might not have thought about before. What is a document? From the raw simplicity of .txt to the locked down world of .doc, or the open structured beauty of XML, we're diving into how our digital files evolved and why open standards matter more than ever. I'm your host, Richard Brock. Let's get this podcast open. Michael, welcome to the podcast. Today we're going to be talking about file formats and file editors. This is something I understand you have a certain amount of experience with.
Well, I think so, yes. So I've spent some years working on that. So of course I helped found the Document Foundation with many other talented people, and I've worked on Open XML standardization with ECMA. So Open XML is Microsoft's file format. I've been intimately involved with the Open Document format, which predated that. I guess as a developer on that, and now perhaps in a business context, the CEO of Collabora Productivity. And I suppose if I look back in time, I worked, a long history, 8-bit micro, in an 8K ROM, you could get a whole word processor there, word-wise there. It was probably my first one, and now, of course, 64-bit spreadsheets, just giant gobs of data, and the code size is huge these days, of course.
If you had to pick a number, how many file formats would you say are being used today?
Actually used is a good question. So one of the things that actually the Document Foundation has is the Document Liberation Project, which tries to rescue all of these incredibly esoteric old file formats from different word processors. And the interesting thing is that some of those pieces of software are still in use today by small niches. It's amazing how they've survived. But of course, the majority formats are, the Microsoft formats and the Open Document formats there, I guess. That's the vast majority. Hundreds, maybe, but trillions of documents in the mainline formats.
The question I want to ask today is, why do we have so many formats? Where did they come from? And how did we go from plain text to the modern word processing behemoths that we have? So is it fair to say that .text was the first digital file format?
Well, of course. Storing a whole series of characters one after another is kind of the basics, isn't it, really? And everyone really starts there, and then they sort of move on. Then they want to add formatting, or they want to add sort of command codes to it. So even the very early systems, troff or something has a full stop, and then you can put a command, if it's on a blank line and so on. And so there's this idea that then you should have extra stuff that's not visible that then appears in the file format, and then that of course gets elaborated. And of course, today we see that in Markdown, I think, is quite a popular use of that people are familiar with from wikis. And also we're familiar with the massive proliferation of different standards of Markdown that are everywhere. And it's amazing that we could teach people even to use Markdown. I think the only reason they learnt it was because they could collaborate. And actually collaboration is such a rich thing that people are prepared to use some horrible user interface and learn these weird codes of double asterisk something as a header, because it lets them then collaborate and publish stuff online in a very simple way.
So we're all familiar with .text. We've all opened Notepad and found it very strange when the line doesn't wrap and no indenting. What might you say was the first modern document editor with real formatting?
Crikey. Yeah, well, that's a really difficult question. So luckily, I didn't spend a lot of my time in the early 80s or late 70s fiddling around with these things. Yes, I mean, clearly Microsoft's Word was there for a long time, but come Word 6, it became totally dominant in the market. So it became 90+% of the market and wiped out lots of the extremely good preceding products, primarily for financial reasons, I suspect. I mean, it was cheap and it was easy to get, and Microsoft had a great channel with the operating system to drive that through. Yeah, and I guess because of that, then we had this kind of monoculture of Word everywhere, which brings benefits. It's very easy to interoperate. If the same bugs, the same problems are everywhere, it's no longer a bug, it's a feature, And if you fix it, maybe your document doesn't look the same everywhere anymore, and so you can end up with these ridiculous, long-standing bugs that just have to be kept. There's a very famous one with Lotus dates, where they have a leap year that isn't there, or vice versa, and so there are some dates that just aren't represented correctly, and because it's a number in a spreadsheet converted into a date, there's just nothing you can do. People could have done arithmetic on it, and they could have treated it as a number for 100 cells and then turned it finally into a date. And so you just can't correct there's just nothing you can do. You just have to use these old bugs, and we bring them forward, which is amusing in some ways.
So in 1983, Microsoft introduces the binary doc format. Perhaps this is related to what you've just been saying with Microsoft being so dominant, but why did this become the dominant force in text documents or XLS? Or...
Yeah, I really do think that is primarily market forces. I mean, we've done quite a lot of work on lots of the other formats of the time. So, there's WordPerfect, obviously, and, there's Lotus, Lotus, I forget what the Lotus product was. Yeah, I mean, they're basically very similar. They use a binary framing structure and they have record sizes, and to a large degree, they like to just dump binary internal structures into the file stream. This is an era predating any kind of security concerns, where compilers are very efficient at packing structures. Of course, in today's world, structures aren't packed like that. There's loads of spare space in these things, and there could be anything in them, like confidential information fragments. But in those days, there wasn't, and so you just throw it all into a binary stream and hope. And also at the time, there was a big object-oriented fetish, let's say. So people were allured by the joys of object orientation, and there were many good things that came out of that, but one of them was sort of making each object serialize itself. So often you'd see an object, serializing itself into a file format and then actually creating all sorts of problems on top of that. I mean, StarOffice, of course, has a binary file format from that time, precursor to OpenOffice, and then LibreOffice has effectively an equivalent binary file format from that era that we still work to import.
And is it right to say that these binary file formats are more compact on an older system?
So that's really interesting. So lots of work goes into a binary format to try and make it efficient. And there's many axes to that. So for example, Excel would page in and out sort of great chunks of memory almost directly out of its internal memory structures into the file format and out again. So that was very good on a computer with very little memory. You could then effectively use the file format as some kind of swap almost, it was just balmy. And where they have records, they're then very closely packed to try and save system memory and try and save file format memory as well. So, individual bits have different meanings and so on. And so they worked really hard to do that. And you would think that these human beings had done a good job. But it turned out, when we created a much more verbose XML, I mean, the XML is significantly larger, 5-10 times larger, depending on the format, that when you zip it down, it ends up being smaller than the human-crafted, hand-done file formats. And there's lots of reasons for that. Yeah, I mean, so the generic algorithms can expose redundancy that is there for a reason. So if you have a large range of something, it can be between 0 and 64,000, then you'd have 16 bits allocated for it. But often you're not using them all, You can have 65,000 styles, but most people use 10. And so there's a lot of redundancy in those. And yeah, just a generic algorithm can come and go, well, this is always the same. We don't need that. And throw it away and squash it right down.
That's very clever. So 4 years after the introduction of Doc, Microsoft creates RTF, which on the face of it is a far simpler and much more basic file format. Why has RTF survived when Doc has fallen by the wayside?
It's a really good question. So I mean, one of the nice things about RTF, and I think RTF is Microsoft's open specification of the past, to sort of show leadership and cross-platform interop, I think, as you mentioned. And it's very easy to generate. So if you're creating a program, it's very easy to spit RTF out of it and to then get a very good-looking document from that. It's reasonably easy to do that, and lots of automated systems did that. And it was used as an interchange format between some of those, historic products there. And, it lasted a long time. Lots of government systems used it because it was indeed an open specification and so on. And yes, I suppose the standards war that predated, open document format was a very good, more sort of exchangeable standard. ODF came along, and then of course Microsoft reacted to that and created their own open XML standard. And then eventually they killed RTF in 2008. I mean, it still exists, but it's not forward, they're not extending it now. So you may lose data if you try and save as an RTF file nowadays.
So at this point, there's a bunch of clever people who realize that there's some problems with doc files or XLS, these binary proprietary formats, and they come up with this clever stuff called XML. Where did this come from? Why did we end up with extensible files? What does this mean?
Yeah, so it's a really good question. So one of the things that I suffered back in the day was reverse engineering these binary file formats. And you're really just presented with a huge dump of raw hex numbers. I mean, it's just quite amazing. And from that, you then have to infer structure and try and pull bits out of it, which can be, depending on the format, is either easy or really, really tricky. So to give you an example, I think I was working on a format, and correctly spelled words were represented differently to misspelled words. So one of the things you try and do is when you add a character to the document, you dump it and you see what changed to try and understand the structure of it, right? And that's fine. Of course, things like timestamps and creation times and metadata all changes every time, right? So you can see that just saving the same document again and again tells you those bits, you filter those out. But then, there were really very substantial changes to the structure based on a very simple adding a letter to the end, and you're like, what is going on? It's just a disaster. When it comes down to trying to understand and wrestle with that, the binary format's a real pain to deal with. And the great thing about XML, of course, is that the framing and the structure is well understood, it's human readable, and of course it is extensible, although how useful that is unclear. If the consuming application doesn't understand it, it will throw it away, typically. So that's not too useful. It's also a sort of tree structure, so it's hierarchical, so you even get more structure information about it than these typically quite flat things. And that just makes it very, very easy to process and emit and do clever things with. So there's a huge benefit to that. And of course, XML has these chevrons, and people are familiar with HTML or XHTML would be familiar with the basic structure of that. Obviously, much less tolerant of not closing things properly and so on than browsers are. But yeah, just a very nice way of representing data.
So how do we deal with that structure and the difficulty with parsing that?
Yeah, so parsing is then the process of sort of turning that back into something we can handle and the computer can understand and deal with. And that's actually quite slow. So XML is a very powerful representation, but that brings a number of downsides. You can extend it with all sorts of clever entities and references. The spec is very large. And if you look at how it's actually used by office productivity apps, typically none of that stuff works. If you want to do whacked out stuff, knock yourself out, it just won't work when you import it. For many reasons, like it's a good idea not to go and download bits off the internet when you're trying to parse your document. So unfortunately, that adds some complexity to parsing and tokenizing, so turning these things into numbers a computer can understand. So when it says, paragraph or something, then we need to know, the computer needs the number, pretty much. And we have a very clever, actually Collabora has a very clever parser in the LibreOffice technology there, that is essentially constant time XML parser. So people come up to me and go, I've discovered a way of parsing XML much quicker. And it's a fair challenge to try and do that. And I say, well, that's fine, but we have a constant time parser. It doesn't depend on the length of the file. And they look at me and they think, how can you possibly parse a potentially infinitely length file in a constant time? And of course, the answer is, really, we don't. It's kind of a cheat. But we have an extra thread, and we do the parsing in a thread, and then we throw the results over in a much more computer producible form to the main application that then proceeds and consumes that. So as long as your application is doing a fair bit of work, consuming it, and we can parse faster, it's effectively free if you have a free thread. And in modern processors, of course, there's a free thread all around every corner, right? So
this is the sort of thing that would have been impossible even 20 years ago?
Yeah. With old systems, unless you've got free hardware sitting around that's looking for something to do, absolutely. And actually, the really nice thing about this is if you look at how XML is parsed, typically there's a thing called a SAX parser, and what it does is it does a very little bit of parsing. So it understands one small part of the XML, and then it tells the application, do this, and the application goes and does something very expensive. And then it comes back, and then it parses the next bit of XML. But the way CPUs work is that they like to try and do the same thing again and again and again, and they have caches and all sorts of branch predictors and optimizers that make that really fast to do the same thing again and again and again. What they don't have is resources that allow you to do a little bit of this, a little bit of that, a little bit of that, and then sort of mash it all together into one flow. And so actually, in addition to having effectively this constant time and this free work in the thread, it's actually far more efficient on hardware resources on both sides to split that out. So we're really pleased by that.
That's very interesting. I'd love to talk to you another time about the use of hardware there. So we then end up with these modern file formats, things like docx, SLSX, or the open document formats, ODT, ODP. They are an XML file. They are what's going on? What is a docx file?
Yeah, so that's a really good question. So the open document format started all of this, and we have essentially an encapsulation, a zip file. So both docx and ODT are zip files, and actually if you rename it from .docx to .zip, you'll probably be able to just browse inside it and have a look, which is great. So we also have a thing called flat ODF, which is our equivalent of the RTF, very easy to generate, very easy to output, and that essentially turns everything into one XML file. But the problem with that is if you have an image, like, a picture of something beautiful, you essentially have to base64 encode that to turn that into plain text, which blows it up. And then you have this great big XML file you have to handle with this huge blob in it. And it's kind of ugly. What would be really nice would be to have a zip file with a separate picture in it, and you can load the file and, there are all the pictures that are in my document listed in a folder there. And so if you look in an ODT file, you'll see there's a pictures folder there, or if you look in a Microsoft file, we often have a Word media folder, and the image will be in there, and that's just a great way to separate the various different bits of your document. And then, of course, it just depends on the structure of the application. We obviously, with ODF, really tried to separate styles from content. The separate styles files and separate content files and files describing it and settings for application. There's all a stream for everything. And then if you have an embedded document inside it, so you can embed a spreadsheet in a word processing document, you're going to have a sort of recursive substructure of spreadsheet with its own pictures, and and it's turtles all the way down. I promise you, I've been down. So yeah, it's how it works.
So why didn't Microsoft reuse ODF?
That's a good question, and obviously they would need to answer that in some ways. But I think there are a number of things that are kind of obvious. So I was involved in their first standardization meeting, actually in Brussels, with ECMA when they put out their draft to ECMA, and it was huge, and that's a good thing. It's great. Microsoft really focused on jamming all of that legacy from their 30 years and standardizing it all and putting it all in the standard. Now, of course, LibreOffice, OpenOffice back in the day did similar stuff, but we tried not to put it all in the standard because we wanted something that would be more easy to use, more human readable, I think. So if you look at the XML structure from Microsoft, it's really focused on mirroring that binary internal representation much more, which can make their filters faster in some ways, but that's not a huge win. And it can kind of make it harder to read and understand. So instead of things that look like HTML, where you have, my name is bold, Richard, say, close bold, you would have all sorts of different span descriptions of elements of text and so on. And it can be harder to see and read. It's a minor difference. Almost no one reads those file formats. Almost no one knows that there's a zip file you can go into. Yeah, so I think they thought they could be more efficient. Much with any sort of secondary implementation of something, there's some efficiency wins there that you get, particularly the way they structure the spreadsheet. LibreOffice Collabora Online will load spreadsheet tabs in parallel in Microsoft because there's multiple separate streams. So we can be parsing and also interpreting 8 streams of XML in parallel, for example, there. And of course, in ODF, it's all in one large stream. So there are limitations there. So there are advantages and disadvantages. They're not very substantial. They're effectively equivalent. They take their internal model and they dump it to just a different XML representation.
Just before we draw to an end, some people might be saying this is very academic, but I suspect some of our listeners will have had the experience of opening a document in multiple document editors and occasionally seeing some minor differences. For example, I was recently working on a presentation, an ODP file in LibreOffice and Collabora Online. I also opened it in Microsoft PowerPoint and was very surprised to see that I had lost all of my page numbers. What's going on here, and how do we reconcile these differences?
Well, it's a really good question, Richard. I mean, I've just looked it up, and it's incredible. But actually, it's a great example of a missing feature. So sometimes you've got 2 models here, 2 pieces there that are involved. The core functionality, what PowerPoint has, and then the filter that brings it in. So there's a piece of software that's got to read that format and then map it to the internal structures of PowerPoint. And you're absolutely right. It seems incredible, but there's a field in LibreOffice and Impress and Collabora Online that has the total number of slides. And you just drop it in your slide template, and then it's this is slide 8 of 10, and it just isn't in PowerPoint, which is quite surprising. So instead you need to write of 10 or something literally on the thing, and then when you add a slide you need to change it manually to of 11 or whatever, which seems balmy. I mean, you can argue here that it's a bug in our export filter that we should know that they don't have this feature, and we should manually flatten this field to say of 10. And of course, that's a great shame when you reload it in, but because it's an ODP file, we can't do that. Like if we were exporting to PPTX, we would know that the feature wasn't there and flatten it. But because it's an ODP file, Microsoft should really do that themselves, either in their import filter or better still, add the blinking feature to PowerPoint. It's an extremely simple feature to add, isn't it? Let's face it. So that's one case where the filter is wrong. And the problem is that we can't fix this. Like, there's nothing that we can do on our side to make that better in Microsoft Office. Certainly with ODP, which is our preferred file format. So that's one kind of problem. The other problem is where the functionality is there, but there isn't stuff in the filter. So, for example, in Microsoft Word has a very powerful change tracking model. Collabora Online has a very powerful change tracking model. So we export the data to our ODT files, and Microsoft simply doesn't import it. It flattens it as if you've done accept all changes. You lose all of your changes. All your redlining is gone when you import it.
That doesn't sound good.
Yeah, that's not great. So, oh well, hooray, we all agree on the contract, brilliant. So, of course, if you use docx format, then we export, dutifully we do our job and we export it to the docx format. So it is possible to do. It's not even difficult. And then, that then imports into Word. So you can get the data through using their format because we've done a better job of implementing that. Their filter is poor. So sometimes there's a core functionality that's missing. Sometimes it's a bad filter. The big picture is that it works really well, and we work really hard on interop and getting this right. So one of the reasons that we really need open formats, I think, is around innovation. If you change the suite to add a radical new feature like the number of slides in a presentation, you need a way to be able to serialize that into the file format and extend the file format, and then communicate that and standardize that with other implementations. And so the open document format allows that extension, ability to extend and grow the file format. And so, that's something that the world needs, I would argue.
Well, thank you so much for sharing with us. It's been very interesting to hear about this. We look forward to having you back on the podcast soon.
My pleasure, Richard.
That's a wrap on this episode of Open Matters. If you enjoyed it, please do subscribe, share, and let us know your thoughts in the comments, because being open matters.